All right, so just to finish this up. So the cloud model of the atom agrees with Bohr that electrons can only exist in discrete states of defined energy, and that they can jump from one state to another by absorbing a photon of light, and when they fall back down, they emit it. But where they don't agree with Bohr is that these discrete states are not these well-defined orbits like Bohr spent so much time trying to find the radii for, okay? But rather they see the discrete states as clouds. And just like a cloud doesn't have a defined border, then that means atoms don't have a precise boundary or well-defined border or well-defined size. Okay, they call these discrete states orbitals. Okay, and so from now on, we will refer to these discrete states as orbitals. We can use Schrodinger's equation to calculate the size and the shape of these electron clouds for the different orbitals for a given atom. Okay, we could also use Heisenberg's matrices to do the same thing. Okay, so for a ground state in hydrogen, the electron cloud is actually spherical. But then when you go up, the next one is like dumbbells, and there's different shapes, okay? So the cloud then is interpreted as the probability of finding the electron. It's like the probability distribution. Okay, so it's like graphing the probability distribution. And the more dense the cloud, the higher the probability that it'll be there. The less dense the cloud, the less the probability of it being there. This cloud model also suggests that each orbital can occupy 0, 1, or 2 electrons. 0, 1, or 2 electrons only, and no more. And that if there are 2 electrons in the same orbital, that they cannot have the same spin. They need to have opposite spins, so one spinning clockwise and one spinning counterclockwise. And I suspect somewhere in your life you would have seen someone, I'm thinking chemistry, draw your electrons as little arrows with a spin up and a spin down. But it's really talking about spinning clockwise and spinning counterclockwise, so they have opposite spins. Okay, so for hydrogen and actually for other atoms, the n equals 1 is usually a sphere. The n equals 2 orbit, and I'm doing capital, but it really should be small, I think. There are 3 pairs of dumbbells or barbells from the like the gym. Okay, so what does that mean? It means there's a high probability of finding an electron out here, a low one in between, and then another high one out here. Okay, and the low one in there because the central orbit, the n equals 1 orbit, would be in here. Okay, so I think I'm going to stop there just because I don't want to ruin. I asked you to research your people, and I don't want to go too much further because I'll end up talking about all your people. I've already talked about Schrodinger, Heisenberg, Born, so I want to give you a chance to read a little bit about them. So next day in class, we'll pretty much cement this, okay? So please, for tonight, find info about your people. Thank you for tomorrow. And it'll be like a 2-minute presentation that you'll share with the class what you found out about who they were and what they did. Just 2 minutes, not 5, because we don't have that much time.